right, so what is the equation to blow, and how do you specify our kV energies? So this is TG61, but it's not just TG61, it's TG61, which is kV calibration, and this specific equation is for water. Now we know this for a couple reasons. First of all, we have P sheath. The air version of TG61 does not have sheath. It's in air, so you don't need a sheath because you don't need to worry about the chamber being water protected. Our energy absorption coefficient, there we go. It says water. That should probably clue it in right there. But then also we have this PQ chamber, not stem, like the air had. So there are differences you should immediately be able to pick up on and tell the difference. And those are a few of those. So let's hop into what this really means. So here we have Z equals 2 cm. That means we are taking our measurements at a depth of 2 cm in water. Then also, something important to note is this is really only 100 to 300 kVp according to TG61. So if you have something like 40 kVp, you need to do it in air. And you really need to know the differences between these for your exams because you don't know which one of these equations they may ask. And so it's important to know both of them. So the low energies of the secondary electrons let us use the mass attenuation coefficient rather than stopping powers, which note in TG51, that's why we're using stopping powers. But here, because of the low energies of the secondary particles, that's why we can use this factor rather than our stopping powers. So going back, similar to the air, NK is still our air Kerma calibration factor. Then we have our PQ chamber, and that simply is perturbations due to our chamber. So remember, similar in TG51, you want that dose to water at that point as if you didn't have a chamber there. Same thing here, but you do have a chamber, so there are going to be perturbations and there's going to be just issues and change geometries and interactions because of the chamber's presence. Now, specifically here, you are going to look up the half value layer, which again, actually, we'll just answer the second question. That is how you specify kV energies. Rather than a percent depth dose or a percent depth dose 10x, we're using half value layers. So look up HVL and your chamber specifically. That is how you're going to determine what your PQ chamber is. Now, P sheath, this is perturbations due to a sleeve, and we've already talked about why that matters. You're going to use your half value layer and you're going to look up your sleeve type. And then we've already mentioned that we can use these attenuation coefficients rather than the stopping powers. So that's TG61 for 100 to 300 kVp, kV beams. And if you have any questions, please comment below. Again, it's very important you know the difference between these two equations. But I think you got it. Study TG61. And if, like I said, you have any questions, comment below. I'm happy to help. Best of luck studying and good luck.